everyone, welcome back to our CoffeeJUG online events. Today we're happy to see Rafael Benavides from Red Hat. But before I give the stage to Rafael, I want to give special thanks to our Ukrainian armed forces who continue to fight for our freedom day by day and push back the Russians. And yeah, thank you guys. In community we trust. This is our main credo here in CoffeeJUG. We already organized more than 39 events with more than 500 unique participants. Want to thank you to our organizers Andriy, Uliana, and Igor, and to our program committee member Olesa and Alexei. To our partners, Sombra and Grid Dynamics, who in these difficult times continue to support our community, and to our community partner JetBrains. Want to remind you that at the end of this presentation, we're going to give 2 licenses for free for the best questions. Rafael will choose the best one. And yeah, those licenses for any JetBrains products for 1 year. So be active and don't hesitate to ask questions. Remember to join us in Facebook, Twitter, and Telegram. And Rafael, the stage is yours.
Hello, everyone. It's nice to be here at the CoffeeJUG. By the way, just a curiosity for those people who didn't know about me. I've been to Ukraine twice. I've been to Lviv and to Kiev in 2018, if I'm not wrong. So I love Ukraine, and I'm really, really happy to be here presenting one more topic to everyone. So what I will present to you today is about how to perform distributed tracing using Opentelemetry. In the past, I used to talk about open tracing, but now open tracing is dead. Open tracing became Opentelemetry. So as I was presented, so I will skip this slide and go to do a trip for a moment where we didn't have DevOps. Right? Today DevOps is reality, but a long time ago we didn't have DevOps. So it was just imagine a situation where it was just another day in the IT department of any industry, of any customer, where we developers we were just throwing our jar files on the top of the operation people, right? There was the wall of confusion, there were silos, and that was fine while the server was up, right? If the server was up, everything was good. But if the server went down, if the website was down, if the services stopped, it looked like the end of the world. So everybody, you can remember, right? I think everyone faced this situation where the server was down, the service was down, and everybody started screaming. They are losing money, they are losing customers, they are on the news telling that your website was down. So it's almost the end of the world, right? But some things never changed. The ops people say it's not an issue. We have monitoring. We know that the website was down. But what the operation people see is just a red light in their monitoring screen. And let's be honest, a red light does not help anything unless we become aware that the website was down, right? It does not help to recover from a disaster, to recover from a bug. In this case, we need developers. And what we developers do, we say peacefully, just like this guy from this show. I love this show. And he peacefully says, what does the log show? Because once that we have the log in our hands, we can understand what's going with the software, why it crashed, right? So because there was silos, right? The operations people were the only people who touched the server. They were before DevOps, the only people are allowed to read the logs. So when they read a log from any server, they see things that they couldn't understand, right? So developers, what they should do at that time, they start screaming, "Show me the logs. I want to see the logs." And when we developers finally read the logs, we can understand that what caused the failure. Was it a timeout? Was it out of memory? Was it unable to connect to a database? Any kind of error, right? But we can understand better the logs than operations people, because operations people they are not really aware how to look on a stack trace, on a Java stack trace, for example. So we become like Neo, understanding things in the matrix, right? Okay, but let's talk about the present. I was talking here about a situation where we didn't have DevOps, but nowadays we have DevOps as part of our culture. We don't have the wall of confusion anymore. So we don't only have DevOps, but we have nowadays microservices. And when we talk about microservices, we don't have everything to deploy together. We have all the microservices spread on different servers in different deployments, creating a network of services, right? And so we had in the past a monolithic application connected to a single database. Now we have multiple deployment units running on top of containers, managed by Kubernetes, for example, connected to multiple databases. So this is the new school that we are living today. But some things never changed. People of the operation still saying, but we still have monitoring. But let me show you something really funny here. We don't talk about monitoring anymore. We talk about observability. And I really like this sentence from Cindy Sidrahan. He said, observability because developers don't like to do monitoring. So we need to package it in a new nomenclature to make it palatable and trending. So when we hear about observability, we are still talking about monitoring, right? But observability is more it's more wide, right? Because we have three pillars of observability. We can observe our software in a sense of logging, right? We can watch the logs to watch what our software is performing or performed in the past. We can watch our software in the perspective of metrics to understand how it's behaving in terms of memories, thread pools, connection pools, allocation of resources, and we can see also the perspective of tracing. This presentation will focus on tracing, okay? And when we talk about observability in these three pillars, we need to understand also about a specification called Opentelemetry. So Opentelemetry is a specification, right, that will help you as a developer to instrument, generate, collect, and export telemetry data. What data? The three pillars: metrics, logs, and trace. Okay, Opentelemetry is part of CNCF. And as I mentioned before, it was a merge of the open tracing, which was focused only on tracing, and the open census project. And the idea of Opentelemetry as a specification is to provide only the APIs with no relations with platforms and vendors. Okay. And what composes Opentelemetry? It's composed by the specification itself, and it's specified what is specified in this specification. The Opentelemetry protocol. So every time that you see this letter OTLP, it means Opentelemetry protocol. The semantic convention, that I will talk more about the semantic convention later, and the APIs to generate the data, right? we can have the libraries to implement the client instrumentation and the Opentelemetry collector, because we need to collect those data and send to a telemetry backend. So you can see here. So for example, our source code will use the SDK of Opentelemetry to export the data to the collector. The collector needs a receiver, and it also has its own exporter to export those data to the backend. It can be a console, it can be um, a database, it can be a software that will show the tracing data, which I will talk more about that using Jaeger. Keep this name in mind, okay? So I have some questions for you here. When you see this kind of layout, where we have a client doing an API call through a load balancer, and the load balancer will call the authentication, the billing, and the resource allocation on API. If you watch this, can you say what is the invocation order? If the client will go to load balancer will allocate the resource first, then we'll call the authentication to perform the billing. We don't have that idea unless we see those numbers here. 1, 2, 3, 4, 5, 6, 7, and the response 8. But is it in parallel, or is it serial? Can I invoke the billing and the resource allocation at the same time? What is the latency, or how long it took to perform the authentication? How long it took to perform the billing, or how long it took to perform the resource? Suppose that the client invokes this API in the web framework, and it took like 30 seconds to reply. Why is it slow? Why is it too slow? Is it the authentication? Is it the billing that's communicating to the credit card? Is it the resource allocation? We don't know the amount of time, the latency. Or in a cause of error, the client will see only 500 error, right? An error has occurred. So who caused the error? Those are the problems that we can solve if we change our way of seeing the software to a timeline view. For example, in the timeline view, we can see that the client transaction started from the start to end, the load balancer transaction from start to end, and then we had the authorization first. Then in serial, just after the authorization, we had the billing, and the amount of time, more than half amount of the time was spent to resource allocation and provisioning, because we had time to container startup, storage allocation, startup scripts, right? This way, it's much better to see the amount of time that it took to perform an operation. So why tracing is important? Because when we have microservices, we have several services communicating to other services. So we need to understand what is the critical path, what is the latency, how long it took to invoke a server, and in a case of failure, why did it fail? Why? What caused a cascading failure, right? So tracing is important because of that. But before understanding tracing, we need to understand some terms. What is the terminology of distributed tracing? The first thing that we need to understand is a trace. The trace is when you click a button. When you click a button, you are performing an operation from the beginning to the end. And when you perform an operation, it will cause a span of multiple operations, multiple microservices. So when you click on an operation, an example operation, you will call the microservice A, that will call the microservice B, that will call the microservice C, then microservice B will call microservice D, and microservice A can call the microservice E, and each one of these, everything in a click is a trace, and it's a collection of spans. Each one of these items here is a span. So what is a span? A span is the operation itself. So inside a span, we have the name of the operation, we have the start and the finish timestamp. We need to understand how long it took to perform that operation. We have the status. Is it okay? Is it it's completed with okay? Is it it was completed with an error? We have attributes for that operation. We have events for that operation. We have a context, and we have a relationship with other spans, right? And we have a kind, because a span can be a server receiving requests, can be a client performing requests. We can be producer in a case of asynchronous calls, and we can be a span. An operation can be a consumer or it can be an internal, just like a method call. A method call is internal. It's not server, it's not client, it's not producing, it's not consuming. It's just an internal call, right? So a span link is a reference to another span. It can be a child of or a follows from. Child of is when you one span is child of another span, just like the name says. Or follows from is when it's a serial call, when you have a span calling another span and it calls another span. Okay, span attributes. So an operation can have attributes that they are tags of key value pairs, but they are user-defined annotation of spans, and they need to follow the semantic convention. So let me open the semantic convention here. Pay attention. So for general semantic, we can have the server address. Let me increase the font size here. We can have the server address, the server port. Let me see what else we can have here. If we are doing an HTTP call, we can have the HTTP response status code, the body size, what else? The protocol name, if in this case HTTP or speed, protocol version, network transport, 3CP or UDP, what else? And we have semantic conventions for messaging, for exceptions, for even for GraphQL or AWS lambdas. Okay, let's return here. So we can have examples: DB instance, DB statement, DB type, HTTP method, as I mentioned, as I said to you, HTTP URL or status code, span kind, client, what is the component, what is the error, and we have the span events. Span events is just, it's also a key pair value, but it's more used for logs. So, for example, what is the log examples? Message opening a connection to MySQL server, or message can't connect to MySQL server, or another kind of logs that you can end in an operation, like performing operation A, performing operation B, C, or D. Okay, and we have also a span baggage. The span baggage is also a key pair value, but it cross boundaries. You can propagate from one operation to another. So it's placed inside a baggage, and it's propagated from one span to another. Okay, so this is next span example. We have the context, which is the trace ID, the parent ID, right? The ID of the span itself. Then we have the name, the kind. Remember, internal, server, client, consumer, or producer. The timestamp, start and end time. The status code, which can be code unset, error, or okay. The status message, and the attributes using the semantic convention. Okay? Now, see, if Opentelemetry is as a specification, we need to have implementation. And Jaeger is a tool that became open source by Uber, and it's used for distributed tracing. It's compatible with Opentelemetry and can perform data model instrumentation library. It contains instrumentation libraries for Go, Java, Node, Python, C, C++, C#. And how does Jaeger work? By the way, if you are familiar with Spring Boot, you probably have used Zipkin, and you might think about zipping at this moment. But I like this explanation here on why Jaeger is becoming more popular than Zipkin. This blog here mentions it has an analysis of Jaeger versus Zipkin for open tracing distributed tracer. By the way, if you want to have access to these materials, you can go to this link here, okay, bit.ly/CNCF Opentelemetry, and you have access to the slides. Okay, you can feel free to copy, to download. It's open, right? So this blog says that despite Zipkin being around for a while longer and being more mature, Jaeger has seen some good adoption thanks to several factors, such as a good language coverage of open tracing compatible clients, low memory footprint, and modern and scalable design. So how is the design of Jaeger? Jaeger, you have two ways of collecting data with Opentelemetry and using Jaeger. You can have Opentelemetry collector as a sidecar or host agent, or Opentelemetry collector as a central cluster. In both ways, you can have your application using the Opentelemetry API to instrument the code. The Opentelemetry SDK will send the traces to the Opentelemetry collector. The Opentelemetry collector will send those traces to Jaeger collector according to the adaptive sampling, which means will I get all traces or just 10% of the traces? For production, maybe 10% is okay. And for development, maybe 100% of the traces is okay. Okay, plus some sampling config. Okay, now it's my favorite time. Let me show you two things. I have here in my local host Jaeger running. Okay, so this is the console of Jaeger. And you can see also my application running here. I will perform my application. I will not explain to you what my application is doing. Instead, we will use Jaeger to explore what are the operations of my application. Okay, so let me call it here serial. Let me increase the font size. Let me invoke serial. Okay, microservice A received my parameter here. Let me use CoffeeJUG. CoffeeJUG. Now, microservice A called microservice B and stored saved to that database, and this is the counter. My microservice A called microservice B and saved to Kafka, and microservice A called microservice B that invoked microservice C and said, hello, CoffeeJUG. Okay, let's explore this in Jaeger. So here in Jaeger, I can go to the system architecture, and I can go to my design architecture graphic, and I can see microservice A invoked microservice B 30 times, and microservice B invoked microservice C 10 times. Why so? Because microservice A call microservice B 3 times, right? And microservice B call microservice C only 1 time. That's why for each 3 calls to microservice B, there is 1 call to microservice C. Okay, so we can see the number of invocations here. Microservice A does not talk to microservice C directly, and we can go to Jaeger UI and look for operations. We can look for the microservice here, microservice A, B, or C. I can query the operation name. I want to see all operations. I can use the tags about the last 5 minutes, max duration, minimum duration, and limit results. So let me find the trace of the last 5 minutes. So in the last 5 minutes, I have this call here. Let's take a look. Microservice A. If I open it here, we can see that I have the name of my code, the name of my package, the name of my class, REST resource, my IP address. It has the method get, the content length, the HTTP route. I have here the path, it's localhost 8080, as we can see here, right? What else we can see? We can see information about the process, and then we have another call to another method here. So that's why the span kind is internal. And microservice A at this moment will act as a client. Why client? Because it calls the microservice B. So it's a client of microservice B in the port 8080. And it will call debug, that calls to database CoffeeJUG. So we have microservice B receiving the request, and we can go here, DB endpoint, storing the database method, and we can go until this until saving my my data to database. So we have here the Opentelemetry library, Hibernate, and we can see even the insert message to the database. So we have the operation here, insert into message content and ID, the values as a kind. Then microservice B calls microservice A calls microservice B for a second time at the Kafka endpoint, right? Remember here, we are just like here, the second invocation. So storing to Kafka, we can still track and trace what is the operation. So we can see here that it has published to my topic on Kafka, right? So it was the span kind is a producer. And finally, microservice A called microservice B that called microservice C. Microservice B here is microservice C is let me see here if I can find it. It's a Node.js application. So I placed a Node.js application here to show that we can communicate different languages. By the way, microservice A is a Quarkus, microservice B is a Spring Boot, and microservice C is Node.js. So we can still have Node.js given us information. By the way, let me see if I can find it here. Process. Let me just close everything. Microservice A. Let me refresh. Process. Hold on, I'm trying to find here an information about the process. I'll show it in another opportunity, right? Because what I want to show you is what happens in a case of error, right? I will simulate an error here just by stopping my SQL. By the way, look here, I use Docker Compose. You can see my Docker Compose here where I have my SQL running. I have Jaeger running. Right? I have Kafka and Zookeeper running. And I have microservice C, microservice B, and microservice A running. Okay, so let me stop MySQL. Docker Compose, stop MySQL. Okay, MySQL is not running anymore. So I will try to access my operation. Look here, pay attention to this. I have an error, right? So, but why? And let me find the results. I can find it here. What happened is that microservice A, there is a timeout with microservice B. So what is the error? I can see the logs here and have saying the exception. Reads timeout. But microservice B is still trying to talk to microservice, to the database. Okay, so let me keep refreshing. Refresh, refresh, refresh. I still have microservice A. Now I have microservice B. Microservice A failed fast because there is a timeout. We saw the timeout error here, right? This is the cause of this screen, the internal server error. But after some seconds, we had another error, which we can also see in the tracing. We see the error here in the tag. We can see error true, right? Status code error. And in the logs, we can also open the logs and see exception. We have the stack trace here that caused the error. And what is the error? Let's see. Unknown host exception, MySQL, because I stopped MySQL. Let me start MySQL again. Okay, let me refresh and everything back to normal. And we can see now my operation completed. Microservice C has never been called because this is a serial invocation. So microservice B will not try to store in Kafka. It will not try to call microservice C because it stopped on trying to save the database. Okay. Now that you saw open tracing working, let me give you more details on how you can use open tracing, right? So it's really basic to use open tracing API. You need to instantiate a tracer, and there are different approaches by language, by framework. If you use C# is one way. If you use Java is another way. If you use Node.js another way. But once that you have the tracer object, you can just call this following operations. Span builder with the name of the operation, start span. Then, if you want to create an attribute, you will call set attribute, the name of the tag and the tag value. If you want to create an event, you will call span add event. Let me see if I can show you an event here. So let me get this, save, logs. Here, you have an event. I have an event here. I wrote this in my in my source code. Let me show it to you. This is the microservice C store in the database. So let me open here, microservice B, source Java, my service, store in the database. Hold on a second. Let me see. Microservice B, store in the database. My service. Here. I got the span, the current span, and then I called the method span add event store in the data in DB called. It's what you see here. Okay, just like we saw in this slide, span add event, and at the end you just say span end. Okay. Well, and we also saw the tracing propagating its context from one service to another, right? We had the microservice A calling microservice B, right? And we propagate the context over the network, over the HTTP call. And how was that possible? That was possible because in the Zipkin era, there was what was called B3 headers. The B3 headers was this collection of HTTP request headers with the name of trace ID, parent span ID, span ID, and sampled. There was 4 headers to propagate data from one microservice to another. Now, then with Jaeger, Uber created the Uber header. So it's just one header called Uber Trace ID, where you have the trace ID, the span ID, the parent span ID, and the flags all together. And now, the DoubleTree org, now it's part of the specification of HTTP. We have a trace parent. We can even open here the DoubleTree org, and we can see details of the specification. So we have the trace parent, trace states as part of the header. Let me see if I also can see in the logs. Let me see here. Here, you can see trace parent and the data of the trace. Okay, so it's part of the W3 org now. So this header is propagated from one microservice to another. So we have the transaction ID, the trace state, and trace parent specified in the header. That's why we can do the relation between a microservice A calling microservice B. We can even see here the name of the header, the name of the name of the trace. By the way, you in Jaeger you can change here to graphic. Okay. By the way, if you want to see this way, or if you want to have a statistic, flame graph, yeah, etc. Another feature of Jaeger, by the way, is that you can compare 2 traces. Okay, so I can select 2 or more traces. Okay, and then you can compare and see what happened. This is really nice. And here you can see the details of each span. But let's return to open tracing. How can you do to perform Opentelemetry with Java microprofile? In this case, I use it Quarkus. It's automatically. You just include the microprofile, there is in microprofile, we have the Opentelemetry specification. So it's automatic. Okay, so every JAX-RS server will be traced automatically. But method calls, we need to annotate with the annotation with span, right? So let me show you here. Let me show you. Microservice baby. Here, we can just use this annotation with span, which is part of Opentelemetry. And JAX-RS client calls are also made automatically. And asynchronous call, we need to activate the span in the synchronous thread. Because, for example, suppose that you are doing a parallel call, right? Let me show you here. For example, in this serial call, we can see that microservice B started after microservice. My call to Kafka started after my call to that database, and my call to microservice C started after my call to Kafka. But I can also have a parallel invocation. And in this case of parallel invocation, let me find it here. We can see that they started in parallel, right? I didn't need to wait this task to start this, and I didn't need to wait this task to finish to start this. So they are in parallel. So what I need to do is inside my completable future method, I need to call server to get the server span and make it current inside this thread. Okay, so that's why I placed this information that inside a synchronous call, the server span needs to be active via API in the asynchronous thread. If you are a Spring Boot agent, it's really easy. You just need to use java dash jar and use the Java agent and the path to OpenTelemetry agent. How so? You can look here in my Docker file. I have my microservice B from Spring Boot. I copy the OpenTelemetry Java agent to my Docker file, to my image, and I execute with Java agent Java telemetry jar and the name of the jar. Okay. And then my REST controllers are on server are traced automatically, and method calls I must use with span annotation, just like microprofile. It's part of the OpenTelemetry specification. And what about databases? If I want to trace databases, I can use the OpenTelemetry JDBC instrumentation. And how I can use it? I use the OpenTelemetry driver, and in front of the driver, I use my connection string OTel, the OpenTelemetry. It's really, really easy. So let me show you here. What's the driver that I used? OpenTelemetry driver and OTel of OpenTelemetry in my connection string. Really, really easy. For Kafka, I just need to set the property producer config, interceptor class config, and use the name of tracing produce interceptor. If I'm consuming, I can use tracing consumer interceptor class for consumer config. So really, really easy also. I don't think it's the case of having Node.js developers here, but here I have a sample code of how creating a SDK. We need to import OpenTelemetry data and instantiate a Node SDK, configuring the trace exporter, the metric reader and exporter, the instrumentations, and resources, where I can give the name here microservice C. The good thing is that OpenTelemetry can be configured with environment variable. What kind of configuration can I give? So many configurations, but there are some specials, which is the OpenTelemetry service name, where you can give the name of the service, resource attributes, protocol, the endpoint, where I will send the data. In my case here, I will send to Jaeger at this port 4317. Okay, so if we go back to our Docker host, Docker Compose, we can see for microservice B, where I will send the OpenTelemetry telemetry protocol data. For Quarkus OpenTelemetry exporting OpenTelemetry traces endpoints. For microservice C, I also have configured OpenTelemetry exporter OpenTelemetry endpoints. Okay, so it's really easy to configure. And I cannot finish this presentation without talking about Istio, because if you are familiar with Service Mesh, before Istio, we have inside microservice A, microservice B, and microservice C, we had to place our code related to this to discovery, load balancer, resilience, metrics, and tracing. But with Istio, all those things can be placed inside a sidecar container, right? So Jaeger is part of Istio. We have Jaeger. If you use Service Mesh, if you use Istio on Kubernetes or OpenShift, for example, we will have Jaeger. But there are some things that we need to understand. The Istio sidecar proxy, which uses Envoy, generates initial B3 headers. So we need to configure our OpenTelemetry protocol to propagate data using B3 headers. Okay, and also the sidecar will process inbound and outbound requests, but there is no implicit way to correlate the traffic from the sidecar to your application. So your application needs to get the inbound traffic, the inbound context from Jaeger, from Istio, sorry, replicate and propagate it to the other and propagate it to another to the call to the other microservice, right? This is part of the documentation. We need to it's not automatic, right? It's not using Istio and everything is ready to start tracing. We need to make our applications aware of of tracing data using Opentelemetry. Okay. Well, I also like to place here information on how to instrument code. So there is a nice tutorial in the Opentelemetry website where you can learn how to perform manual and automatic instrumentation for C++, .NET, Erlang, Go, Java, JavaScript, PHP, Python, Ruby, Rusty, and Swift. Right? Let me open it here because this is really nice. So you can have automatic instrumentation and manual instrumentation. Let's get Java, for example. So traces, metrics, and logs, the APIs are stable. And here, what are the Maven dependencies that you should use? If you decide to use automatic instrumentation, it's easy as placing Java agent with the name of the service. And if you need to configure the agent, there are some examples here. Or if you decide to use manual instrumentation, there is also a nice tutorial here. So it's really, really nice. That's why I placed it inside this slide. And also, if you want to look at the demo that I used, I have here the source code of microservice A, microservice B, and microservice C. Suppose that you are a microprofile or Quarkus developer, you might want to take a look here. If you are a Spring developer, you might want to take a look here. And this is really nice to start playing. And it's really also easy to play with this demo because you just need to call this script that will perform a Maven clean in the Java. Let me increase the font size. Maven clean for microservice A and B, and npm install for microservice C. Perform a Docker Compose build to create the image, and Docker Compose app to start the demo, as I did it here. It's really, really easy to try this demo. Okay, or you can even take a look at the Docker Compose here to see the configurations that I used. Okay, this is the end of the presentation, but it's not the end of this session because now I will take a look on the questions that you might have. By the way, if you are at Twitter, now it's called, it's the former Twitter, right? Now it's X. If you're an X user, you can go and look for my profile name, Rafa Bene, and I will be happy to keep in touch with you. Let's go and take a look on the questions, right? Let me stop sharing and see the questions here. Hey, we are glad to have you joined here. Okay, so question, how does Opentelemetry ensure minimal impact on application performance while capturing tracing that data? Excellent question. And the answer to that is that the instrumentation is performed asynchronously. So it's more or less like they are asynchronous call, and most of the time the protocol uses gRPC. So it's lightweight, it's performatic, and asynchronous. So the kind of impact that you will have is more related to network, because if you start tracing everything, Jaeger, for example, will be overloaded with requests. Your network will be overloaded with requests and tracings and traces being sent. Then your application degrading slowly because of the amount of tracing that is doing. Okay. Is there any more questions?
Okay, guys. So I see no questions yet.
Awesome. That means that people are understood everything,
Yeah,
or they are a
y-
little bit shy or
yeah,
tired.
you're such a great speaker, so everyone understands what you're speaking about.
Thank you.
Yeah, I guess you could choose at least one person who would receive the JetBrains license.
And how can I do that?
I don't know. Let
Let me see. Pay attention. Let me open my Twitter, and the first people who mentioned this talk with the link of the YouTube, um, uh, YouTube record will be the person who will receive the JetBrains license.
it's
And
totally
don't forget
great
to
of
mention my name because I need to see it here in
yeah,
my
sure.
notification. Go.
So you already posted, yeah?
Yeah, I'm watching the. Let me share here to see. Let me share. I don't have any notification besides this one. Let's see. Who will win the JetBrains license?
Yeah, probably to not. I
So
don't know.
let's
To not wait. Yeah,
let's
we
give
could.
the JetBrains license.
Yeah, to Ihor Banadiga who mentioned it.
Yeah, let's give the JetBrains license to him.
Okay, okay, it's fair enough. Thank you again, Rafael, for such a great talk. It was nice to see you and to listen you. Really nice. Thank you.
Thank you also. And feel free to invite me more times. It's really a pleasure to talk to CoffeeJUG. And I wish all success. I really love the Ukrainian people. And I really wish from the deep of my heart that that you get successful and stop this war as soon as possible.
Thank you, Rafael.
Thank you. Bye bye.
See you.
See you.
And guys, thank you again for all of you who find the time today to join to us. And thank you to Sombra and Grid Dynamics, and to our community partner JetBrains. Don't forget to join us in our social medias in Facebook, Twitter, or X, and Telegram account. Thank you all, and see you.